Hey, what's going on? Today we are going to be learning about binary molecular nomenclature. Remember that molecular is also a term that refers to any compounds that have covalent bonds. So what is nomenclature? You can see here by the definition that this is the way we name things in science. The root nomen refers to the Latin for name. So we're going to talk about how you give names to these compounds that are molecular and binary. So what is a molecular compound? A molecular compound is any compound that has covalent bonds. And simply put, a covalent bond is a molecule that has two non-metals combined. In this example today, we're going to be talking about binary molecular, which means it has specifically only two types of elements. The prefix bi, like di in science, means two. You can see some examples here. NH3 has nitrogen and hydrogen. Even though there are three hydrogens, there are only two types of elements represented. The same is true for CO2 and H2O. And while some of these do have common names, today we're going to learn about the true naming system for these compounds. So when naming covalent compounds, you're going to notice that a lot of prefixes will be used. And it's really important to note that this is the only time that prefixes will be used. There are other times where you will name compounds in class, but no other time will there be prefixes to indicate the number of atoms present in the compound. So anytime you need to remember, think of CO2. You all have learned this name and know it well. This is known as carbon dioxide. You'll notice that carbon and oxygen are both nonmetals, and the prefix di indicating that there are two oxides or two oxygens. So here are the first 10 prefixes that you'll see, and not all of these are as common as some, but be familiar with them all. Most you've heard of before. One means mono, like mono a mono, one on one. Two is di. We saw bi earlier, but when it comes to naming most things, we'll use di. Everyone knows tri, three, like a triangle. Four, tetra, we learned in talking about molecular geometry, but remember tetris, every shape made up of four blocks. Five, penta, like a pentagon. Six, hexa. Seven, hepta. Eight, octa, like the octet that every atom wants in its valence shell, the 8 electrons. Nine, nona, and 10, deca, like a decade. So how do you name covalent compounds? Well, first let's look at the nonmetal that starts it off. For that first nonmetal, you're going to add a prefix to the name to indicate the number of atoms. The name itself stays the same. There is one exception though. If that first nonmetal has only one atom, then you will not add the word mono. For example, earlier when we named CO2, we did not call it monocarbon dioxide, we simply called it carbon dioxide. So you never use the prefix mono on the first nonmetal. Your second nonmetal will also add a prefix to the name to indicate the number of atoms. However, unlike the first one, its name does not stay the same. Its name's ending changes to IDE. So let's go through a few examples. In the first compound, as well as in all of them, you'll see that there are two types of atoms present, two different elements in each. You'll notice also that every element is a non-metal. In our first one, we have two nitrogens and one oxygen, so the prefix di and mono will be used, and giving us dinitrogen monoxide. Notice how the first name's element stayed the same. Nitrogen kept its name, just had the prefix added. Notice how the last name changed its ending to "ide". Oxygen becomes oxide, and the prefix mono was blended in. Followed by carbon tetrachloride, sulfur hexafluoride. Spelled incorrectly, but it's okay. The next one, diphosphorus pentoxide. Notice the penta had the A dropped and was also blended in, and you'll see that with most names that start with vowels. Boron trifluoride. You all should be familiar with the next one, water's name, dihydrogen monoxide. Again, di meaning two hydrogens and mono for one oxygen, compared to H2O2, which is dihydrogen dioxide, commonly known as hydrogen peroxide. So how does it come to writing formula covalent compounds? Going backwards, you're going to do the exact same thing, and you're going to see the same properties are true, two nonmetals. The chemical formula you're going to see will show the element symbol, followed by a subscript, which indicates how many atoms are present of that type of element in the compound. Remember, if there is no subscript, then you are assuming that there's only one of those. Examples, H2O has two H's but only one O. NH3, one H and one N and three H's. And then the third one is actually called ternary, not binary, because it has three or more atoms, where you see one carbon, three hydrogens, and one bromine. Again, reviewing our common prefixes, you will see these same prefixes used. The prefixes that come before the first nonmetal indicate the subscript for that element, just as you saw in naming compounds. And same idea as before, when there is no prefix in that first nonmetal, you're going to assume that they are meaning that there's only one. Now for the second nonmetal, the prefix that comes before it will also indicate the subscript for that element. Dinitrogen pentoxide means we have two nitrogens, five oxygens. Arsenic trichloride has no prefix in the front of arsenic, which means one arsenic. Chloride, referring to chlorine, with the prefix tri means there's going to be three chlorines. And going through this process, you can see how all of this works out pretty nicely. Dinitrogen for two nitrogens, monoxide for one oxygen. Tetraphosphorus, P4, dihydride, H2. Silicon, Si, tetrafluoride, Fl4. Carbon monoxide would just be simply CO, and carbon dioxide, you all know, would be CO2. So overall, this is how you name binary molecular compounds. So let's do some practice. Number one, what is the formula for dinitrogen trioxide? Number two, what is the formula for silicon dioxide? Don't accidentally pick A, which is sulfur dioxide. Number three, name the compound SO3. And finally, number four, name the compound P2O5. Refer to your periodic table anytime you're not sure the element's name. Alright, so now you all should be ready to name any binary molecular compound. Thanks.